Hello again, students. Now this is lesson 2.2, which is doing two-step equations. Let me share my screen with you. Okay, now a two-step equation is very similar to what you learned in lesson 2.1, a one-step equation. You still use IOB, which stands for isolate, opposite, both. Again, that's isolate, opposite, both. Isolate the variable by opposite operation to both sides of the equation, or both sides of the equal sign. So when you have a two-step equation, it kind of goes in this order. First, or number one, IOB is applied to all addition and subtraction first. Okay, so do all addition and subtraction using IOB first. The second step, IOB is applied to all multiplication and division second. Okay, now in most problems, after you do part 1 and part 2 here, then you will be done with the problem. Part 3, if there is a fraction, multiply to eliminate the fraction first, okay? Now I don't mean like a regular division problem fraction, but like if everything is stuck in like a numerator in the fraction, okay? So let's go ahead and practice IOB to addition and subtraction first. So first I want to isolate the variable, of course. Now, I like to think of it this way. Multiplication and division, as you can see, show up much closer to the variable. So we're trying to isolate the variable, so we take away the things that are far away from the variable first, and then we, once those are removed, then we take away the things that are close to the variable. Okay, so since plus 4 is literally further away than 3x, I get rid of the plus 4 first. So isolate by opposite operations, so I subtract 4 from both sides. And I now have 3x equals 8. Okay. Now, the second step, IOB is applied to multiplication and division. So, in this case, I'm going to divide both sides by 3. And I end up with x is equal to 8/3. Now, 8/3 is actually a reasonable answer. It's not in simplest terms, but it is a reasonable answer, so we'll go ahead and leave it just in that form. Okay? Let's go ahead and do the second problem here. I have 7x minus 2 is equal to 5. Again, I want to isolate the variable. Now I'm applying opposite operation, or IOB, to addition and subtraction. So there's some subtraction here, so I must do the opposite, or undo the subtraction with addition. And I do it to both sides. Isolate, opposite, both. So now I have 7x is equal to 7. See how I eliminated the 2 by adding it to both sides, or I eliminated the minus 2. Okay, so now I do IOB to both sides again. And I have x is equal to 1, because 7 divided by 7 equals 1. Okay. Yeah, so go ahead and take a look at this. All right, hopefully there's no questions. Now, I didn't save a lot of room for this problem, so I'm just going to go ahead and I'll rewrite it a little bit lower here so that you can see how to do this. X over 8 minus 4 equals 2. All right, first step, isolate using IOB for addition and subtraction first. So we will add 4, oops, not 8, add 4 to both sides. So 2 plus 4 is equal to 6. Bring down my equal sign. Negative 4 plus 4 is equal to 0, so I don't have to write the 0 in the next step. Now I have x over 8 is equal to 6. Eliminate the 8 by opposite operation. Yeah, I want to isolate x by the opposite of dividing by 8. The opposite of dividing is multiplying. When I multiply by 8, it cancels the division. So then I have x here. Now I have to multiply this side by 8 as well. 6 times 8 is 48. So x equals 48. Oops, I just realized I'm off the screen here. Hopefully you can see that. X equals 48. Now, continuing on, let's go ahead and look at the next problem. X minus 7 over 3 is equal to 12. Now, this is where I go to step 3. If there is a fraction, multiply to eliminate fractions first. And when I say there's a fraction, I didn't mean like this problem where we just did everything by IOB to negative 4 and then IOB to x over 8. I mean that I have an expression stuck in my numerator here, okay? So in order to simplify that, I have to get rid of this 3. Now I'm going to change colors here just to make it easier to see. So before I can isolate, what I want to do then is eliminate the fraction by multiplying by 3. Now when I say eliminate the fraction, remember every fraction is basically a division problem, okay? So here I have x minus 7 over 3. It could be said as x minus 7 divided by 3. When I multiply by 3, I undivide or cancel the division that was here, okay? Now remember in the last lesson I showed you a scale. Well, the scale shows that everything is equal. So in order for this to stay equal, I must multiply times 3. 2 times 3 is 6. 1 times 3 is 3. This was negative and that was positive, so my answer is negative 36. So I now have x minus 7 equals negative 36. Okay? So what I did was by eliminating the fraction, I multiplied this, and so now I have an expression here instead of an expression stuck in a fraction. But I have to do the same to the other side to keep it equal. Remember, just like the scale. If I put something in one side, it goes down, but I have to pick it up and then make sure that they're even, okay? So now let's finish the problem. I want to isolate, opposite, and both. Okay, so in this case, I have negative 7, so I must add 7 to cancel that out, and it becomes 0. Okay, I must add 7 to this side. Now I want to remind you the rules of integers. If the signs are the same, do what the operation says. If the signs are different, do the opposite operation. So I have negative 36 and positive 7. So I do the opposite operation. Isn't that right, Hector? Yep, you got it. So I have negative 36 plus 7 would be the same as saying 36 minus 7. Okay, so 36 minus 7 is 29. Now in my mind, I just said 36 minus 6 is 30, minus 1 more is 29. So just a little trick you can do when you have numbers like this. Now, the greater absolute value, the greater distance from 0 is 36, and since that one's negative, then my answer is negative. So I have x minus 0 is equal to negative 29. I don't need to write the minus 0 for my solution, so I'll just write it without that, and now I have x is equal to negative 29. Okay? Now, one more thing I just wanted to show you just to avoid confusion. Let's just say you have a problem like this. Negative x plus 2 is equal to 9. Okay? This will be our last problem for this lesson. So first step, I want to subtract the 2 from both sides. 9 minus 2 is 7. So now I have negative x equals 7. Now again, like I said in the last lesson, if you have a negative variable, then that means negative 1 times that variable. So this looks like a solution. You're like, oh, well, it's a negative solution. Nope, it's not a solution because x is still not isolated. There's a negative sign next to it. So isolate by dividing by negative 1, or opposite operation, to both sides of the equation. Now in this case, the negative 1 here cancels the negative 1 there. Even though you can't see the 1, you just see the negative sign. So then I have left with x is equal to negative 7. So technically it still is a two-step because you had negative 1 attached to your variable. Okay, I hope that helps. Thank you very much. Call, text, or email if you have any questions.